Hello everyone. In this class we will discuss class 12 physics, electric charges and field, the important MCQs. So look at the first one. A static electric charge produces. So static means the charge is at rest. So when the charge is at rest, it produces only the electric field. So correct option is A. Look at the next one. The question is, when some charge is placed on a good conductor, then where that charge will remain. So the option number A is it remain in the same position, it goes to the center of the conductor, remain on the surface of the good conductor, or none of the above. So the correct answer for this question is charge will always remain surface of the good conductor. Okay, look at the next one. The next question is, in nature, amount of electric charge possessed by an isolated system is always first 0, equal to multiple of square root of fundamental charge, integer multiple of fundamental charge, or multiple of square of fundamental charge. So the correct answer is C here. It is always Q is equal to N times E. So it is always integer multiple of the charge. So correct answer is C. Look at the next one. For making any neutral body positively charged, so to make the body to be positively charged, we have to what? We have to do what? Remove the electron from its surface to make the positively charged body. Look at the next one. A spherical shell and solid sphere made up of the same material having the same radii are charged to that maximum capacity if the charge on the surface respectively Q1 and Q2. Then we have to find out the relation between the charges. So when electric field on the surface of the shell and sphere can have maximum value equal to the dielectric strength of air, which constant. Okay, both the sphere we have charged with maximum capacity. So the electric max on the first sphere, let's say electric field is E1 maximum, and on the second sphere maximum, which is both the equal to, let's say, E dash. Okay. So electric field formula is kq upon r square. So kq1 upon r1 square is equal to kq2 upon r2 square. So k and k will get cancelled, but it is given that both the sphere have same radius. So r1 and r2 both are equal. So r1 square r2 square will get cancelled. So the answer is q1 is equal to q2. Option number C. Look at the next one. Coulombian force between two charges. So between two charges, so if suppose both the charges are like charges, then the nature of the force is repulsive, and both the charges are unlike charges, then the force is attractive. So it can be attractive, it can be repulsive. So the correct answer is C here, may be attractive or repulsive. Next question. While rubbing two appropriate bodies, positive charge is produced, negative charge is produced, no new charge produced, none of the above. So the correct answer is C, no new charge is produced, because charge can be only transferred from one body to another. We cannot create or destroy. Next question. When glass rod is rubbed against the silk become negatively charged with 320 Coulomb. Then how many electrons are lost by the glass rod? So charge on that silk is given with negatively charged 320 N times C. So Q is given minus 320 because it is negatively charged, so minus 320, and electron value is nothing but minus 1.6 into 10 raised to minus 19. So if you apply the formula, Q is equal to N times E. So charge is given minus 320, okay, into this will be nano Coulomb, so 10 raised to minus 9 is equal to, and we have to find out, and Q value is, E value is minus 1.6 into 10 raised to minus 19. So if we take this minus 1.6 into 10 raised to minus 19 in the denominator, so minus 320 into 10 raised to minus 9 upon minus 1.6 into 10 raised to minus 19. So this minus will get cancelled, and if you cancel out simply, okay, if you remove the decimal, then it become here in the numerator 32 into 10 raised to, if we add this 0 here, it become 10 raised to minus 8 upon this becomes 16 into 10 raised to minus 18. So 16 to the 32. So two answer is there in first three option, but if we check the power, if we take this negative 18 in the numerator, it become 10 raised to minus 8. Sorry, this become a 20. This is 20 here. So minus 8 plus 20, which is nothing but 10 raised to plus 12. So 2 into 10 raised to plus 12. Correct answer is option number C. Next question is, two identical spheres A and B have charge Q and Q by 2 respectively. If they are brought in contact with each other, then separated, then charge on each of them will be. So the sphere A has charge Q, sphere B has charge Q upon 2. So if we bring in contact and then separate, then after the separation the charge will be nothing but average of both the two. So Q plus Q by 2 divided by 2. Okay, we have to take the average simply, nothing else. So 2 into Q, 2Q, 2Q plus Q, 3Q upon 2 divided by 2. So this 2 will come in the denominator. So the charge will be 3Q by 4 on each sphere. So the correct answer is D. Look at the next question. 80 microcoulomb charge is given to a sphere of 4 cm radius and 40 microcoulomb charge is given to a sphere of 6 cm radius. If they are connected by conducting wire, then the charge transferred from one sphere of radius 4 cm to sphere of radius 6 cm will be, means how much charge is transferred from the first sphere to second sphere, let's say A and B. So first of all, let's calculate the total charge. Let's say first sphere has charge 80 and the second sphere has charge 40 microcoulomb. So total charge will be Q is equal to Q1 plus Q2, 40 plus 80 is nothing but 120 microcoulomb. So if we connect by the conducting wire, okay, and after that if we separate them, so after connecting the conducting wire, the charge on the first sphere, let's say Q1 dash, we can find out by using this formula. Q means total charge multiplied by radius of the first one upon total radius. So total charge is 120. First sphere has radius 4 and total radius is 4 plus 6, which is nothing but 10. So 120 multiplied by 4 upon 10. So if we cancel out this 0, 0, so 12 4s are 48. So the charge on the first sphere is 48 microcoulomb. So in the starting, originally first sphere has 80 microcoulomb charge. Okay, now it has 48 microcoulomb. So how much it transferred from one to second sphere? So 80 minus 48, which is nothing but 32 microcoulomb. So total 32 microcoulomb charge is transferred from the first sphere of radius 4 cm to the second sphere of the radius 6 cm after connecting by the wires. Okay, so by using this formula we can easily find out the charge after connecting. Look at the next one. The next question is, two copper sphere A and B have equal radii. If sphere A has 100 electron and sphere B has 400 protons, then what will be the electric charge on each of them when they are brought in contact and then separated? Okay, so let's find out first of all total charge. So Q is equal to Ne, that is our basic formula. So sphere has 100 electron, that means N1 times minus E. So N1 is 100 electrons, so 100 times minus E, that is minus 100 E. And then sphere B has 400 protons, that means plus E. So 400 times plus E, so minus 100 plus 400, nothing but 300 times electron. So total charge is 300 E. So E, the value of E will substitute here. So 1.6 into 10 raised to minus 19. Okay. So if you multiply 16 3s are nothing but 48. Okay. Now after that we are separating them. So we have to take the average of them, means half of that. So 4.8 into 10 raised to minus 17 upon 2. So if we take the half of 48, it will be nothing but 24, which is 2.4. So the correct answer is B. Look at the next one. So again the same type of question, but here we have to find out only net charge of object having 9 into 10 raised to 13 protons and 6 into 10 raised to 13 electrons. So again the same formula, Q is equal to N times for electron will use minus E and for proton will use plus E. So how many protons are there and electrons are there? So electrons are 6 into 10 raised to 13 into minus e, so minus e, plus protons are 9 into 10 raised to 13 and plus e. Okay, so if we take e and 10 raised to 13 common, so we will remain minus 6 plus 9, which is nothing but 3. So 3 multiplied by 10 raised to 13 times e. So if we substitute the value of e, which is nothing but 1.6 into 10 raised to minus 19. Okay, so if we just multiply the number 16 into 3, that is nothing but 48. Okay, so we have two options with 48. This is negative, so this is wrong. So we will solve the power. If we remove this decimal, then this 19 become minus 19 become minus 20. So minus 10 raised to minus 20, and this 13 we have to solve. So minus 20 plus 13, which is nothing but 7. So the correct answer is B1, 4.8 microcoulomb, because here only 4.8 is given. So the correct answer is B. Look at the next one. Next question is, in which of the following cases attraction is maximum and between two charges separated by 2 mm distance? Okay, so distance is given, we want attraction to be maximum. So for which charges we will get attraction? For unlike charges. Okay, so option number B, both the charges are like, so here we will get repulsion, so this is wrong. This is also like charges, so this here also we will get repulsion, we want attraction, this is also wrong. So we will get attraction in option number D and option number A. But we know that the force of attraction is directly proportional to the product of the charges. Okay, so if the product of the charges is more, then force is more. So here the product is q into 2q, which is nothing but 2q square. But in the first option, 2q multiplied by 2q, which is 4q square. So here the product is more. So the first option number A will have more attraction. So option number A is the correct answer. The next question is, Coulomb's law is represented by F is equal to K q1 q2 upon, we know that upon is r square. So here r raised to n is given, but not in the division, it is a multiplication. So if we take r raised to power 2 in the numerator, we can write down as K q1 q2 upon r raised to minus 2 if it is in the numerator. So the value of n is here minus 2, not plus 2. If it is in the denominator, then it is plus 2. If it is right in the numerator, then it becomes minus 2. Look at the next one. So this is a theoretical based question. Coulomb's law is correct for dash distance. So the correct answer is greater than 10 raised to minus 15 meter and less than 10 raised to plus 18 meter. Next is based on the graph which represents correct relationship between Coulomb's force versus distance. So we know that Coulomb's force is inversely proportional to the distance square. So distance increasing, then force decreasing. So the correct answer is D. The next question is, if F1 bar and F2 bar are two forces acting on electron and proton placed in uniform electric field respectively, then. So we know that on both the charges, whatever force is there, okay, let's say proton and this electron, this is let's say F12, this is F21. So both the charges are same in magnitude but opposite in direction. So the correct answer is A. The next is based on the same concept. The ratio of force acting between two charges respectively 2 microcoulomb and plus microcoulomb on each other is. Okay, so one is 2 microcoulomb charge, other is plus 5 microcoulomb charge. So both are positive, so the force is repulsive force. Okay, but whatever force this 5 microcoulomb charge acts on the second charge, and whatever force is from 2 microcoulomb charge will apply on the 5 microcoulomb, both are equal in magnitude, okay, but opposite in direction. So if you find out the ratio by taking the modulus, okay, so the ratio will be nothing but 1:1, because both are in equal magnitude. So if you divide, you will get the answer 1:1 only. The next important question is, the distance between 2 point charges 4q and minus q is r. Okay, so one charge is 4q, other charge is minus q. The distance between them is r. if the third charge q is placed at their midpoint. Okay, this q charge is placed at the midpoint. That means the distance from the first charge is r by 2 and distance from the second charge, that is also r by 2. So the resultant force acting on minus q is 0. Okay, so the net force on this minus q is 0. Then we have to find out what is this value of q. So there are two forces on this minus q charge. One is a force due to plus q charge and the other force is due to on the 4q charge. So if you apply the formula of force, F is equal to K q1 q2 upon r square. So the force due to the 4q charge will be F is equal to K, q1 is 4q and q2 is nothing but this minus q, that is q square, q into q upon the distance from 4q to minus q is nothing but r, so r square, and the second force will act, that is due to this plus q charge, so that force will be F is equal to K. So one charge is plus this capital Q and the other charge is this minus q, so we will take positive only because modulus is there, and the distance between that two is nothing but that is r by 2, so r by 2 the whole square. So the force will be K q upon r square upon 2 square is 4, that will go in the numerator. Okay, so it is given that the net force is 0. That means the force due to 4q charge plus the force due to plus q charge is equal to 0. Okay, so if we take this force to be this side, so F4q is equal to Fq. So we have to just equate this two forces, nothing else. Okay, here minus sign will come. So K times 4, this q into q will be q square upon r square is equal to minus this force, that is K q small q into 4 upon r square. So this r square will get cancelled, k will get cancelled, 1 q will get cancelled. Okay, 4 and 4 will get cancelled. So what will get, q is equal to nothing but 1 minus sign remaining and 1 q is remaining, so q is equal to minus q. So the option number A is the correct answer. The next question is the position vector of 2 point charges 2 microcoulomb each. Okay, so both the charges are 2 microcoulomb, 2 microcoulomb, are 2i cap plus 3j cap minus k cap and 3i cap plus 5j cap plus k cap. So the magnitude of Coulombian force acting between them is. So first of all we have to find out the distance properly. So this is a vector form are given, so we will subtract that to find out the net distance. So the second minus first we have to subtract. So 3 minus 2, which is nothing but 1 I cap, then 5 minus of minus become plus, so 5 plus 3, sorry here it is plus 3 cap is there, so 5 minus 3 will be 2j cap, and this k minus of minus plus 2k cap. So we will find out the r by using the x square plus y square plus z square, so 1 square plus 2 square plus 2 square, the resultant distance, which is nothing but root 9, that is root 9 is nothing but 3 meter. Then we apply the formula, that is our F is equal to K q1 q2 upon r square. So k value is 9 into 10 raised to 9 and q1 q2, so both the charges are 2 microcoulomb, so 2 into 2 4, and micro means 10 raised to minus 6, so 2 times 10 raised to minus 6 become 10 raised to minus 12, divided by r square, so r is nothing but 3, so 3 square is 9, so this 9 and 9 will get cancelled, so the answer is 4 multiplied by 10 raised to this 9 minus 12, which is minus 3 Newton. Correct answer is A. Look at the next one. Force acting between two equal and unlike charges at a certain distance is F. Okay, so two charges are there, equal and unlike. So let's say first charge is Q, second charge is minus Q. So force between these two charges is nothing but F is equal to K Q1, that is Q, Q2 is minus Q. So if you take the modulus plus Q upon, let's say distance is r, so r square. After that, what is the force acting between two charges if 25% of the charge is displaced from the one charge to another? Okay, so let's say 25% of the first charge Q. So 25% of Q is nothing but Q into 25%. So if we convert into remove the percentage, 25 by 100. which is nothing but 1 by 4. So it is q by 4. Okay, so total charge is q and 25% of total is q by 4. So we are removing that, so it is nothing but q minus q by 4. So if we do the cross multiplication, so 4 into q, 4q minus q, which is 3q by 4. So this is a total charge now on the first one, and this charge q by 4 we are adding in the second charge. So second charge is minus q, in that we are adding q by 4. So if we solve that, q into 4 into minus q minus 4q plus q, so it is nothing but minus 3q by 4. So if you apply the formula, okay, so now we have on the first, let's say, position, on the first sphere, let's say the charge is plus 3q by 4, and on the second sphere the charge is minus 3q by 4 after shifting 25% charge from here to here. So if you apply the formula now, F is equal to K q1, so the charge on the first one is 3q by 4 q2, so it is minus 3q by 4, so modulus will be plus 3q by 4 divided by r square. Okay, so this 3 into 3 9 and 4 into 4 16, so the new number is nothing but 9 upon 16, and the remaining thing q into q square upon r square, which is nothing but our original force F. So the new force, let's say F dash, which is nothing but 9 by 16 times the original force. So the option number C is the correct answer here. Okay, thank you very much.